it is time to get started for the webinar that I'm very excited to share with you all and to participate with you all in. The topic is going to be presented by Chris Merck from Bond Home, but how Bond Home built their in-house observability, and then why they decided to switch to Memfault. So let's get started, actually. We have a few pieces of housekeeping first. Let me make sure that I can switch. So yeah, so we're going to have a little bit of a Memfault introduction. That'll be by me. And then Chris will take over talking about how they built their in-house observability for their own company, monitoring their own devices out in the field. And then we'll make sure to leave a lot of time towards the end. I think it's around like 15 to 20 minutes for any questions that you all may have. We'll get into a few logistical items as well, but how to do Q&A. But first, a very quick introduction of myself. I'm one of the co-founders of Memfault, started the company back about 6 years ago or so. I was a firmware engineer at a company called Pebble. We made smartwatches. We shipped a couple million of them. You may remember them from the Kickstarter days when they raised millions of dollars to build one of the first smartwatches that connected to phones. I wrote a lot of firmware there. I had spent most of my time probably building firmware engineering tools to make the firmware engineers there more efficient, better remote debugging capabilities, better logging, better crash analytics, stuff like that. Took a lot of what I learned to Fitbit when I worked for them. Kind of led in firmware developer tools team, about 3 other engineers, where we built more or less the same things, basically like an early version of Memfault. And then I got very tired of building these tools for companies, the same tool over and over again for other hardware companies. And we decided to build Memfault and try to provide this sort of tool set to every hardware company out there. And I'm glad that Bond Home kind of chose to use Memfault as well. So I'll pass the mic to Chris. You can go ahead and introduce yourself, and then we'll move along.
Sure. So thanks, Tyler. Chris Merck here. I co-founded Bond Home with 2 other partners about 7 years ago. And since then, we've been building smart home technologies, largely in the space around Wi-Fi and RF bridging, and expanding into window coverings and lighting of various kinds, with a long-term vision of really respecting people's privacy in the home and building products that last. And this has been a great partnership with Memfault. I look forward to sharing some details.
All right, thanks, Chris. So let's talk about Q&A really quickly. If you have any questions throughout the webinar, there is a Q&A button that you can click and you can ask questions. We will have somebody on the hook here on our side to basically moderate some of these questions. We'll try to answer most of them during this webinar. Some of them may be better either offline or maybe very off topic, and we may not address them, but we'll respond to you in some way. But we're happy to basically answer as many questions as possible as we have time for during this webinar. So please use the Q&A button. We may actually even do them live if it's a pretty important question to address as we go. So now that we've covered that, let's get into the meat of the webinar. From the Memfault side, what I've learned at Pebble, what I've learned at Fitbit, what I've learned talking to many other companies, is building embedded devices is incredibly difficult. I always think about this in 3 different ways. When you're building embedded devices, you have to first understand if things are failing in the field. You just have to count it. Are they crashing? Are they experiencing issues? Is the device not doing something it's supposed to be doing? First, you just have to understand if they're happening. Second, you have to then figure out what is causing that. You have to understand how to root cause it, how to reproduce it, how to actually fix the issue. A lot of this is looking at code for hours, playing whack-a-mole. And then finally, you have to ship that firmware update. And you have to be pretty certain you have made things better and not necessarily worse. And then this cycle repeats over and over and over again until you've finally decided to either be done with updating the hardware. Maybe it's a perfect piece of hardware. Well, of course, nothing is ever perfect in today's IoT world. Or you've decided to build a new version, deprecate the old one, and you just no longer supported it. But building these devices is hard. It's not as easy as writing software. It's not as easy as writing a mobile application. You can't update it as quickly. And we always have risks of bad firmware updates, either bricking the device or just some sort of environment piece where the device is deployed in the world causes some issues that you cannot reproduce internally. And so we've just heard it's really, really difficult. And it's not like anyone is special in this industry. There are many firmware engineers, many hardware companies that are struggling with this. 50% of organizations take longer than a week to actually find the defects in the field. First, like I said, you have to find the defects. So it's about at least a week generally to find these bugs. It's about 3 months to then fix the bugs per year of engineering time. I think there was also a study a while ago that said that over 50% of time of an engineer is generally spent trying to find or reproduce issues. This is no joke. Fixing bugs takes a lot of time. Writing new code, I think during my previous times was generally the minority of my time spent. And all of the caveat to this is all of this data was collected. We did a VDC research reports. You can actually search it up on Memfault's website. But we surveyed about 700 or more engineers that are in the hardware space and kind of captured a lot of this data. The last stat that I thought was very interesting with this is that for show-stopping bugs, for bugs that actually occur in the field on these hardware devices, it takes more than a week for about half of these companies to ship those firmware updates. There is a huge tail end, I would say. Many companies take a month or 3 months or sometimes never are able to fix these bugs because maybe they didn't build a firmware update or still can't find these hard to reproduce bugs. But again, this is tying to the fact that building these embedded devices, these hardware devices, is incredibly challenging because you have to find and fix, and there's not many tools out there. And so what people do is they build these tools. They build these tools or they buy these tools. 80% of these teams building hardware devices are actually using some sort of remote collection diagnostics tool to collect analytics, collect telemetry from these devices out in the field. And they are experiencing an easier time developing these hardware products. If they don't collect information from the field, it takes about 30 engineering hours to remediate each software defect. If they're using built-in house collected tool or collection tools, or they're using a third-party collection tool like Memfault, they actually can reduce that time dramatically. This definitely makes sense. Building in-house collection tools is going to be very simple. Your firmware engineers are not necessarily trained to build, I would say, like data engineering tools and software tools. And if you just grab something off the shelf, it can be made better and better over time, whether that's open source or a commercial tool. And with these two choices, you now decided, I hope I convinced you that you should have some sort of collection tool for telemetry for these devices out in the field, but your teams face a choice. You can either build it yourself. Trust me, it's really difficult. I've done it 2 or 3 times now. Or you can choose to grab something off the shelf, such as Memfault or another open source tool, and you can use those. And that is why we're here to talk with Chris about his decision to basically first build and then switch over to Memfault for their remote collection tools for their devices out in the field. So I will pass the mic to Chris. We'll do a little bit of a screen share switch here, and we'll get started.
Okay, thank you so much, Tyler. Share. All right, so I would love to tell you about our journey in building and buying observability tools. This is going to be fairly technical because I want to give just a bit of flavor of what it takes to build and maintain these tools. Would love to entertain any questions relative to what we talk about, particularly at the end. Just quickly on who is Bond. So we are based in New Jersey. We have a few technical folks here, but most of our tech team is in South Brazil. The weather's much nicer there. Our mission is to thoughtfully connect underappreciated appliances. So ceiling fans, motorized shades, heaters, louver systems, a lot of outdoor equipment, landscape lighting, stuff that was not within the purview of Alexa and Google Home previously, and we're bringing that in, connecting both with high-end automation systems like Control4 or Crestron, and also with more consumer-targeted things like Alexa. So we have a range of different embedded technologies we're using. There's Wi-Fi to RF bridges that are ESP32 based. Various ceiling fans. Most of the US brands that have, most but not all, that use smart ceiling fans have an ESP32 running our firmware inside. We also have remote controls and some appliances that we make or are working on that are STM32 based. So we actually have a diversity of embedded platforms that we're looking at. A typical customer install can be kind of stylized like this. We've got this is the kind of space that one of our customers might be connecting. So you've got a ceiling fan, a louvered roof system on the top, some heaters, and screens on the sides, maybe in the front. That's a fireplace in the center, and you might have some landscape lighting. So we're trying to bring this all into one app. This is an expensive system. It's really like a lifestyle thing. And if you're hanging out here, having put all of this time, energy, and disposable income into this system, you expect it to work absolutely flawlessly. And so we need to make sure that we have really, really great quality in our control systems and software, particularly on the embedded systems, because we make control systems that run offline without an internet connection. So there's a lot of pressure on us to make the embedded system run very reliably. So when there is a problem visible to the end user, we need to be on top of that very quickly. A firmware crash, not all problems are firmware crashes, but all firmware crashes are problems. The user will notice a glitch, or there will be a brief period of time when the system is unavailable. And so one of the first things we want visibility into are those firmware crashes, and take all of them quite seriously. So let's just map out here what it is that we're interested in observing. So we talked about crashes, but there's other things that would help us understand what's going on with our bond bridge product or the ceiling fans. We want to know API calls. What is the app doing when it's talking to this? What kind of requests are we getting from the Control4 system, the other automation systems in the home that could help tell the story of what's going on with a possibly problem unit. There's health metrics like how much RAM and flash space is available in our database that we want to keep an eye on. We have, like almost every embedded device, a serial port that is just cranking out log messages that make sense to firmware engineers, which is of a lot of value if we can see that remotely. And there's various error and warning flags that we can set, various exceptions and assertions and just helpful warnings that help paint a picture of what's going on with the device. And this is a lot of data, so we can't look at all of this all the time. I mean, who knows what the future holds with automating some of this stuff with AI, but for now we need to be targeted with what we're looking at and when. So at Bond Home, we're paying a lot of attention to observability when we've just released a firmware update, a beta, or a stable shipment to the field. We're paying extra close attention to new issues coming up, stability of the devices, how many devices tried to do the firmware update and never came back, which is a very important number to look at. We get support tickets all the time. We provide customer support for our products and for our partners' products, a big part of our value proposition. And we need to be able to drill into that observability data to support even a live customer support case. Then just frequent crashes that are happening, even if it's not linked to a specific support case, we want to check out. And within our automated test environment, just even before releases go out to the field, we're going to pay attention to these same metrics. And generally, if we have any free time left in our quality team or our firmware team, we'll occasionally just browse through our observability data. Just if we have some ideas of some queries we could run, sometimes we'll will explore this landscape and just find interesting things like, huh, it looks like we have this subtle memory leak that's, that we should take a look at. So let me share a bit about what we built. So this is back in 2019, and we realized that we had a couple basic observability tricks going on, but we had nothing for crash analysis. And our new ESP32 based bridges were crashing, and that made us kind of nervous. So we hadn't heard of Memfault yet, and we were using a SaaS tool called Sentry that was designed for observability into other SaaS tools. And so we kind of followed our intuition and collaborated between a backend engineer and two firmware engineers, and we built our own little crash monitoring system. So we had to we had to make sure that we had debug symbols for every firmware build, whether it was built on our CI or on a developer's machine, and make sure that any firmware image that was getting onto any device, whether it was in our test environment or out in the field, those symbol files needed to be in a canonical place on our S3 bucket. So then we needed to capture core dumps. Now, mercifully, Espressif makes that pretty easy and will capture core dumps for you. But at least at that time, Espressif, they didn't give you enough context. There was a lot of missing metadata for us to be able to make good use of those core dumps. So we ended up needing to do quite a bit of work to modify that. So let's just run through the steps real quick. The embedded device crashes. It writes a core dump to a special core dump partition. It then reboots, powers up, reconnects to the internet, and then it says, hey, I have this core dump sitting here that has a record of my, capturing my main task and a couple sections of main memory, and it then uploads that to S3. Then we wrote a rule on S3 to trigger an AWS Lambda function that fires up and then basically does what a firmware engineer would do at their desk with that core dump, which is loading up scripts from Espressif to unpack that core dump into something that GDB will understand. We then need to load the correct symbol files from a different S3 bucket, and because those are very sensitive, right? The symbol files would allow somebody to very easily reverse engineer the firmware, which would be uncomfortable. And then we need to get the correct cross-compiler, the cross-compiler version of GDB, that like Extensa, that's going to run on the Linux system that the Lambda has to be able to understand that core dump. And if our tool chain changes over time, do we need to pull in a different version of GDB? A lot of questions rise there. Then we have to have scripts that can run GDB, grab the output from that, and process it into something that we want to have as our, put up on our Sentry dashboard and upload it. So it worked. And it was around this time that we had just brought this out that I was in touch with the founding team at Memfault. We were starting to talk about what the solution that they're building, and we said, "Oh no, we got this taken care of already." Talk to us in 6 months. Well, it worked, and you can see here what our in-house observability tool looked like. We can see some back traces here. I can click on them and get a bunch of information that comes up on the screen. And this was useful for chasing down a couple firmware issues. But when we drill into this, we see that the tool we're using to visualize all of this, Sentry, must work marvelously for SaaS applications, analyzing other SaaS applications, but it doesn't really understand that this is an embedded device, right? Most of the stuff on the screen you see at the right here is just cruft having to do with the Sentry SDK trying to understand what's going on in our Lambda function. And it's like information overload, and looking at this dashboard requires you to really understand the limitations of what we're displaying here. kind of confusing those contexts. Am I still screen sharing?
Yep.
Okay, good. Sorry. So these breadcrumbs are misleading, and we didn't get that much value out of this because we just could really see the back traces and not a lot more context. So we could see that the firmware was crashing. Let's drill in a little bit more about some challenges that we had here. So I'll talk about challenges in building the tool and then in using the tool. So one very concrete example is when you do a firmware update, you're booting up your new firmware, you may have a core dump from an older firmware. And something that we just didn't correctly anticipate in our design, we ended up with mislabeled core dumps being uploaded. And we were really scratching our heads about a bunch of back traces that just didn't make any sense. So we had to properly tag like in the metadata of those core dumps. And this was something that like the way Espressif had built it just hadn't really been taken into account. So that was a lot more complicated than we thought it would be. Another one is security. So little embedded systems like the ESP32, powerful as they are, they really don't have the resources to fire up, TLS connections willy-nilly. So we already have a TLS connection for MQTT, and spinning one up for an HTTPS transfer was really stressing the system. And so it's very tempting to cut corners and do things do unsecured transfers for the observability, but it's just not a great idea. So that was uncomfortable and limiting the amount of RAM we had available on the products. We considered trying to chunk it and send it over MQTT, but it was just a lot to work out that we didn't manage to do. And lastly, we needed to work between backend and embedded engineers. And while we love doing teamwork projects, when it's like teamwork to build some internal tool to fix bugs in another thing, it's like that's not how we want to be doing that cross collaboration. We want to be ideating on product and user experience, not so much these internal tools, but unfortunately was something we couldn't just do unilaterally on the firmware team. Let's talk a little bit about using this tool. So I'll just run through some limitations we had with our MVP, right? We could only see the active thread. We didn't work out decoding the backtraces for all the other threads. We couldn't see like local and global variables. This stuff is all in that core dump. It could be done, but it would be like N more Jira cards that push out some other development that features that we really wanted to get built for our customers. So we ended up sticking with this kind of MVP. It lacked a lot of that context. We didn't have logs with it. All of these things could be done. But just the kind of activation energy wasn't there. We wanted to put in a certain amount of energy into building this tool and hoping it would just run. But no one was continuing to add and extend to that. Then we brought in our STM32 platform, and it was going to be basically double the work to basically redo almost everything that we did in order to get observability into crashes on the STM32 based devices. So everything we did worked. It just was limited in the scope of what we could do. Lastly, I'll just show you what this dashboard looks like today after it's been running. We still have a bunch of devices that have not updated to use Memfault. And this is what our Sentry dashboard looks like today. Just based on the symbol files growing and other various problems that we have not debugged, there's basically bit rot here. There's more and more issues cropped up in our plumbing, and you see all these things that say GDB exited, key error, exception. None of these are firmware problems. These are problems with our infrastructure to measure the firmware problems. And all of these things would need to be fixed for us to get back to using our internal tool to solve actual problems in the firmware. There's this little AI button on Sentry where it will like try to help you with a problem, and it writes these cool little limericks and couplets and stuff, but that didn't really help us either. So it's Halloween, so let's talk about bats real quick. So I don't know if you guys are into bats, but they're pretty cool. There's like 2,000 species of bats in the world. That's a lot of species. And bats, they're like blind for the most part. Actually, there's like tropical fruit bats that can see really well and just use their eyes. But most bats do this cool echolocation thing where they can observe the environment around them so they don't like crash into trees, right? So according to Richard Dawkins, the great thinker and science writer, bats evolved that echolocation technology 3 separate times in independent ancestor populations. So if you look at different species of bats, they all have this similar echolocation technology where they'll like make clicking noises and see where they're going. But if you look at how they're doing it, what organ they're using to click inside the ear, they have totally different structures of bones to do essentially the same thing. So thankfully, unlike these blind flying mice, where they can't trade genetic material between species to benefit from the innovations that others have already done, IoT companies have a choice to benefit from the work of others rather than just build everything ourselves over millions of years. So let's take a look at like a crash affecting a couple hundred units and how it showed up in Memfault and how this looked for us. So you can see here, I'm looking at the trace logs, and for this crash, I'm able to actually see what the API requests were going on in the context of this crash. This is like immensely valuable. This is basically the script for how to reproduce the problem. We could see what the iOS app was, what the iOS app was up to. Now, if we drill into the core dump, all of the information on the screen here, unlike with our solution, all of the information here is just tailored to looking at this embedded system, right? We can browse the memory, we can see the registers, local variables at every point in the call stack, and for every single task, we've allocated enough space in the core dump that we have the luxury of seeing all of our back traces. Now, what we're debugging here is we're debugging a deadlock in where we have multiple tasks waiting on the same mutex, and as our firmware code base grew and grew, we ended up with quite a few of these deadlock problems that could be really hard to reproduce. So one of the most like awesome things that we've been able to do with Memfault is have the device trigger a watchdog reset and send this core dump up to Memfault, and we're able to look through every task and just see exactly where it's stuck in the deadlock. And usually the solution kind of drops right out of that. Whereas before, we would get a crash, but only in the active task, which is the crashing task that gives us no additional context. So we would just know that deadlocks are happening, and users were seeing like a 20-minute downtime, not 20 minutes, 20-second downtime. And we would be scratching our heads how the deadlocks were happening. And even if the deadlock can happen on your local machine, at least with the tools that you get from Espressif on the ESP32 platform, if you don't have a JTAG hooked up to that unit when it deadlocks, you're not going to know what the different tasks are doing. You'd have to build a lot more tooling around that. And with Memfault, we're just able to see that from the core dump without having to instrument each of the tasks. So yeah, this is just zooming in a bit on that deadlock example. This was a great one where we turned out to be using the BSD sockets API from within a callback and the thing that implemented the BSD sockets API. This bug was open since 2019. It happened kind of rarely, and we ended up just dropping this minor feature from the product because we just couldn't figure out what was going on. We time boxed twice engineering hours to look into it. And we just said, you know what, this is some issue in LWIP. We're going to just leave it alone. The first time we got the crash in Memfault, because this didn't decode correctly in our tool, we saw exactly what was going on and fixed the problem. So to kind of wrap it up here, just talk a little bit about um, the impact Memfault has had on our issue investigation. I'll be really real about this. So the the biggest thing is that it now makes it just easy to look at any crashes. In the past, we'd often not have high confidence in those crash reports that we were getting, and we'd have to have quite a bit of activation energy. It would have to be a really important problem, and then one of our engineers would go and download the core dump them and spin up GDB on their machine, and then walk through using the GDB command line and explore what's going on. That takes quite a bit of time, and so it would have to be really important. We'd like talk about it in our Scrum call, like, yeah, let's do a post-mortem on this one, and then they do a little report. We do a screen share just to get the information that Memfault just throws up on screen with a click. So that's been really tremendous. That we can now, it's just a standard procedure in issue investigation to just look through related crashes. I mentioned that we're using it in development and internal testing. It's great that somebody's running an internal alpha test and we're able to see those crashes. The developer could respond to that even before you get the issue report. You're like, oh yeah, I thought that might be a problem, and rather than having to have the developer reproduce it at their desk based on what the QA engineer is reporting. Now, for us, we are only using Memfault on a small subset of our devices as we're gradually growing the tool. We're, that's just the nature of how we're using it. So we still have a homegrown solution for tracking some other errors across our fleet. But even with that somewhat limited adoption that we've had with Memfault, we're getting a lot of value out of those core dumps, and it's and one thing I don't have up here on the screen that is really big deal is that even since we've adopted Memfault over the last year, a little more than a year, we just visibly can see new features and improvements to the UI being built, new platforms coming online, deeper integration into the Espressif IDF, and keeping up with the vendors' BSP's changes. And that's all maintenance effort and investment that Memfault is doing in this tool, that even in that subset of Memfault that we're using, it's being invested in, and we're not doing that internally, and that makes a lot of sense. It's being well maintained. We've really had no issues in upgrading the SDKs to get new features. That's been very smooth. And there are a couple serious firmware issues, not like dozens of them, honestly, but there's a couple issues that were serious problems that were showstoppers for our team that were way easier to solve because we had this visibility. So, knowing the kind of visibility we can have, I wouldn't want to give that up. And knowing what it takes to build it, I would not want to have to do that again, kind of echoing Tyler's sentiment. So that's our story, and I would love to entertain any questions you might have for me, and I know Tyler's here to answer questions as well.
That was awesome, Chris. Thank you. I have so many like nuggets of information and I don't even know. Yeah, I love the bat comparing Memfault to bat evolution. That was great. Out of left field, did not expect that. And I didn't realize you actually disabled a feature in your product, and then I'm assuming you basically re-enabled it to see if you could catch it with Memfault, the one where the deadlock was happening.
Yeah.
Got it. How many hours of runtime did it actually take to really experience that bug? Was that like 1,000 hours of runtime, or 100, 10,000? I don't know.
Well, it was actually a logging tool that we have that the problem kicked in after the first NTP update after that was enabled. So it would have to be a unit that we've been debugging remotely with the customer, and then NTP updates some hours later. And then so we were starting to automate that a little bit, and customers were getting units locking up. And so we just had to pull that tool from our customer service dashboard.
Got it. Got it. So it wasn't something that, yeah, it was basically in your support flow that it would trigger. Got it. All right. Thank you so much. I'll sprinkle my questions in, I think, throughout the audience questions. But let's go to some of these audience questions that we have. Let me just bring up the Q&A. The first one I have basically is, can Memfault work with Thread instead of Wi-Fi? I guess this is not for you, Chris. I'll just answer this really quickly. Memfault works over pretty much any transport as long as the data eventually makes it to Memfault services. And so when Chris was saying like they don't want to have their devices create TLF connections and then send very large payloads without chunking it up, that is kind of what Memfault helps out with. The SDK will chunk up the data in whatever size is necessary to get it over the transport. If it's BLE or extended CAN or Thread or Wi-Fi or LTE, whatever the packet size you have, as long as the data eventually makes it to Memfault, we will restitch it together and basically show you all the metrics, the core dumps, or the logs that you've sent. So that's one of the great features of it. I guess for Chris, this is my question. What was the delta in terms of time spent debugging issues if you had to put a rough number on it before and after integrating Memfold? I mean, it sounds like there were some of the bugs that were, impossible to catch. But then other ones that are probably like the standard, like you write some code, you throw it into production or in beta, you go debug it. Those happen all the time.
Yeah, so I mean, many like issues are across in IoT, right? Are not just in firmware, it's kind of across mobile and everything. And this is not a silver bullet, right, that solves issues for you. But when we're looking at specifically the firmware team, where when we have some kind of a crash, if you zoom out to the QA person reporting an issue, let's say, and the firmware engineer fixing it, it's saving a lot of time because you don't need to have the firmware engineer reproduce something blind. You have a crash report from that QA test, and you can see that, connect it to that backtrace. Theoretically, I guess we could have done that with our internal tool, but it just we didn't have the confidence in it because we were getting the back traces were often subtly wrong. So we ended up always having to like reproduce the issue. But when we can look at the local variables and we can see all of the tasks, many times you can just fix the issue and send it to the QA engineer without actually the firmware engineer ever reproducing it. We just fix the issue, right? Fix the issue to say, I think this fixes it. CI rebuilds it. 20 minutes later, the QA guy can test it again. He's already got everything set up on his desk. The firmware engineer doesn't have to even get out the hardware for it. As long as it compiles and passes the CI, it's probably going to fix. We can like fix bugs without getting out hardware at our office in Brazil. So that change in workflow is the big deal.
Yeah, so many teams involved, and I guess that's another question I have, is like, how many teams use Memfault? So you saying the QA engineer, firmware engineers, you're obviously using it. So like, how many departments or how many engineering teams are actually kind of logging into Memfault and using it on a day-to-day basis?
So I mean, our organization, we just take basically everyone and call them the product team. But if you zoom in on that a little bit, we have QA and firmware that's really using this tool, and our QA team is also serving as kind of a second level customer support. So once a customer support issue comes in, if we think it could have anything to do with the stability of the embedded system, like we're gonna check on Memfault. We just drop the serial number from the support ticket into Memfault, and that's just one of the things that we're going to look at as we're supporting a customer. So I guess you could say, second level support, QA and firmware.
Got it. Thanks. A question just came in. I guess so the one issue with using a local debugger connecting to your device via JTAG or serial port is that you have to reproduce the issue, right? Like, unless you're not going to catch a bug that you're trying to hunt down that happens on field devices very easily with remote debugging. But like, how does Memfault compare to your local debugging setup, whether that is JTAG? I don't know exactly what your IDEs your team uses, but like compare that a little bit.
Yeah, so if we just think about the ESP32 based products for a minute, I think we have 2 units that actually have JTAG hooked up to them. And it's rather annoying to get it set up and working properly. So we very rarely used JTAG at our company with the ESP32 platform where most of our devices live. So what we were, we were kind of relying on the backtrace that was printed out by the ESP32 over the serial port when it crashed, which would just show us the active threads backtrace and the little monitor tool on the PC that would decode that with the symbol files we just built. But if we were looking at a customer unit, we wouldn't have that. And if we were looking at even a unit from another, your colleague says, hey, like check out what's going on with this bond bridge, the backtrace wouldn't decode properly because I don't have the symbol files for what they built. So
Yeah.
I mean, so it was basically going from not debugging to having that debug visibility. So yeah, using more like, printf stuff. We get away with that because we at Bond, we run almost all of our software in our firmware in high level emulation. We develop it and run it on MacBooks. And then there's just like a little port layer for running it on the embedded system. So we're very often, like in development, we're able to drop into LLDB and debug stuff there.
Amazing. You guys are ahead of the curve. I used to love debugging, I guess, unit tests and like integration tests of sorts in LLDB back at the days at Pebble. So awesome. And then yeah, just answering, I guess, the second part of the question, somebody was asking like, how does Memfault compare to a typical IDE environment, such as the Sager IDE? And I'm going to answer this one. Or what do you get with VS Code? Honestly, it's pretty much the same. Like you don't get to step-by-step debug execution as the device is running. Memfault will capture a cordon, which is a snapshot of all of the registers, the RAM that you want, the log buffers that you want, the execution trace buffer that you need. But you still get all of the threads, all of the active and the idle threads. You get all of the registers, all of the local variables that have been kind of thrown in on the stack. And you get the global variables, and you can basically dig into like all of the linked lists and all of the state of the whole system. And so you can see like what is currently kind of what its current operating state is. That's pretty cool. Chris, do you use So yeah, you alluded to it that you have Memfault in during the development cycle. I'm curious, like how important is it for you to have it during the development cycle compared to the production cycle or production releases?
So we have a couple products in development, and some of them have Memfault integrated already, others don't. When we have a single threaded application during development, might not be so important. I thought that it would be really important to get Memfault integrated like in the very beginning because it would be like challenging to add the SDK later on, like as an afterthought. But there's actually very little friction to adding the SDK and bringing it into a product. Like it was very easy to bring in the SDK to the ESP32 based product, and and we have like a really complicated build system that we maintain, and it was very well thought out how that's done on the Memfault side. That's made it really, really easy to integrate. So I would love to have Memfault early on in the development cycle, but you kind of get to pick. You're not forced to do it right away in the beginning in order to have it in production, but definitely in verification. Once hardware is leaving our office and going to somebody else, I want to know every time that demo is crashing. So
yeah, and
definitely want it in the verification cycle, at least at that point.
Yeah, I don't know how much you lock down devices. I know some companies will lock down the debug ports or sort of like fuse off certain debugging interfaces. And anytime we had a sealed unit or anytime we basically did that or locked it, we had to make sure that we had, something like Memfault kind of enabled because there's no more going back to serial or JTAG for those devices. And so you need something remote, which is honestly great. Um, there was a question here. I know for a fact, I would say it's very hard to, or it takes a lot of time to train up new engineers how to debug certain types of faults. Memory corruption's incredibly difficult. Hard faults are incredibly difficult to kind of like restitch together, or understand what could be failing. Teaching them GDB or basically letting them learn how to use GDB is a time-consuming endeavor. How long does it take to train up the team to use Memfault compared to basically what you were doing before with even your in-house built tools and just local debugging in general?
I mean, it's basically zero, right? I mean, we've only had three firmware engineers use the tool, but basically just invite them to it, show one link of, hey, this is a crash in something you're writing, and it's like candy. Um, there's no friction. Indeed, debugging like a hard fault on STM32 with GDB is an exercise in pain. You need to like have the
Mhm.
data sheet next to you. Now maybe there's some magic scripts you could bring in, but there's stuff you need to know, and you don't need to know anything beyond just an understanding of memory model and basic C developer stuff. And if you're a C developer, you'll look at Memfault and you'll understand what's going on.
Yeah, I remember the debug hard faults during the days that Pebble and fit in their firmware. One, I had to basically like instrument a few other things within the firmware if a hard fault ever happened. And then we wrote a massive wiki page on like how to do it manually in GDP to make sure that you could get the backtrace successfully. And then I think we finally built some scripting, but it was like, years later after we had learned enough, then it was finally how to decode a hard fault. But it just automatically happens in Memfault because we're storing the state that we need to and kind of restitching everything together in the UI. Have you noticed any performance overhead after integrating Memfault? Like I know the answer. I generally know the answer, but I'm curious. Like, did you actually measure the before and after? And did you see any impact?
Yeah, we haven't measured it on the like runtime in the embedded system. That just was never a concern. What we were concerned about was the transport of the core dump, which is rather large because we have this kind of luxurious core dump partition, and transferring that through MQTT, right? It's like, hey, is this going to be like expensive through AWS? Is it going to clog up that transport? And it turned out to actually be less taxing on the system than running the HTTP transfer that we were doing before, quite a bit less, um, because it's just one it's the same task, and all we had to do was just we put the Memfault transfer on a different MQTT topic structure so that we wouldn't trigger all of our other logging and stuff for every MQTT message that comes through. So then we're just paying like the base, small fractions of a cent per message, and we're not triggering like Lambda functions to do something with those messages, just forwarding it onto Memfault. I understand that not everyone's connecting to Memfault in that way for uploading the core dumps, but for us, it was important to tunnel it through MQTT. And it just turned out to be a negligible cost and no measurable performance overhead. Maybe you have to wait an extra like 1 second for the device to be responsive to the app if it's uploading a core dump, which is totally acceptable.
Yeah, I mean, the device probably just experienced a crash if it's uploading a core dump, so they've already had an interruption already. So, I guess this is more so curiosity from the question from an attendee, but I think it's also a great question to answer. How is it debugging or working with the emulator or emulated software versus actual hardware? Like you're saying, you actually kind of are able to debug in LLDB and kind of do things mostly in software rather than hardware. Like, how was that experience for you? Why did you choose to invest time in building this? I'm curious just to hear your thoughts about it.
Yeah, so we originally shipped an MVP that was Linux based. So we had a process running on the embedded Linux system, and then we chose to like cost reduce and reduce complexity to switch to ESP32. And in that transition, we had an opportunity to make our software platform independent, right? We wanted to be able to ship firmware updates basically develop once for both the Linux platform for the legacy devices, because we didn't want to leave behind our original customers. And so we just invested heavily in platform independent code. And a nice side effect of that was having this simulator. And now our firmware team and our mobile team and our backend team all use the simulator on a pretty much daily basis to test things, because you don't, we have like 30 something different products, different firmware targets we build. So you can just spin up a simulator that simulates that target, and it behaves exactly like that target as far as the app is concerned. Of course, it's running in 64-bit, on Mac OS, and it's just like printing stuff to the serial output on your terminal instead of actually doing stuff with the, an RF radio or something. But I'd encourage anyone to like just do as much high level emulation as you can. Almost all of the bugs that we deal with are reproducible in the simulator. It's more like, but once stuff gets out into the field, though, we don't have the luxury of using that debugger remotely, and so Memfault comes into play regardless of where the crashes are. And then if it is a problem more at the hardware layer or in like LWIP, as I was showing earlier with that deadlock involving the BSD socket simulation, that's something that you wouldn't see in the simulation. You only see on the embedded system.
Yeah, the emulator stuff. Like, you let software engineers be the software engineers, and like hopefully they don't need to touch hardware, debug it, provision it, um, get it all working. I also hope no one has to kind of keep around a JLink just to flash their firmware if they're a mobile developer. So that's awesome. Another question. How long do you think you actually spent kind of building this in-house system? Like, if you had to put an engineering hours estimate on it. And I know you're still using it in some capacity, so like your customer support dashboard probably going to be mixed into that a little bit as well. But
so, like, narrowly speaking, on the core, like just the core dump analysis, that was, a few developer weeks to build it, and then more maintenance and monkeying with it than I'd like to admit. So it wasn't that bad. It's just we couldn't continue to invest and build that out to everything it could be. It just didn't look like a really good trade-off there. So we kind of limited the functionality of that pretty early on. We have invested a lot more in customer service dashboards and things, which goes beyond the scope of IoT observability into like giving our customer service team the ability to see live what's going on in the app and what customers have on their accounts and all the messages going back and forth. And we've invested very heavily in that for the same reasons, that we're using observability more for the engineers, is just so that when we're supporting a customer, we have as much actionable information as we can at our fingertips. And so we built something for the customer service agents. Great opportunity for future entrepreneurs or new Memfault futures to get more into the support side of things. So that tool has had way more effort, like at least like maybe a person year and a half over the last couple of years has been put into building that.
Wow, that's a lot of time. But also, I totally get it. Like, the amount of time. I'm assuming. Well, I'm assuming this was all built from a pain point, and it's the customer calling in and saying it doesn't work, and the firmware engineer being like, "I'm sorry, I have no data."
I'll tell you that on our kind of business to business, where we're providing firmware that goes inside of other companies' appliances, our ability to provide customer support and great customer support live, which is, there's a lot that goes into building a great customer support organization, but a big part of that is the tools they have at their disposal, right? That has been the number one sales point. It's like, wait, we don't have to do customer support because we know how to do that really efficiently. That's been a huge seller for us. So that's observability, broadly speaking, if you include that customer support ability, is something that's visible to every salesperson. That's like their trump card when selling the platform.
That's awesome. And then also, I'm assuming with these tools as well, like customer support is when the customer actually calls in, but you are also finding bugs before they even hit customers or before they even notice. I guess due to the tools that you've built in-house, but also Memfault as well.
Yeah, ideally. I mean, frankly, it is kind of difficult when you're looking at crashes coming in that aren't related to a particular customer scenario to dig into it. So we kind of look at those, and if we have a light bulb moment, then we'll go and fix that. Otherwise, let it go until it's tied to a customer support ticket, or we can see the number of units affected is growing, and then that will get our attention. But we can see all of that and prioritize our efforts appropriately.
Got it. I guess I'll spin one question about a Memfault feature, but back at you. Have you ever found like memory corruption issues or stack overflows? I know you mentioned you found a deadlock using Memfault. Have you ever found any sort of these gnarly bugs using Memfault?
What's really cool is as we've been working with the Memfault team, we've gone back and forth about some of this stuff and said, hey, like we got this Stack Overflow that's being reported as a hard fault. And I think like a week later, you guys had like it's now they're all those Stack Overflows are being tagged as Stack Overflow. So yeah, sometimes it didn't work right. Like nothing's perfect. But the responsiveness of the Memfault team to when something, anything was like slightly off to like talk to us about it and fix it, or if we're doing something wrong, has been really great. So yeah, Stack Overflows are caught. I mean, I guess there's situations where it can't tell that it's a Stack Overflow, but all the ones we've run into recently have been tagged appropriately. Out of memory errors. In terms of like global memory corruption, that's like kind of an open problem in embedded systems. I think you just be careful with your arrays or use Rust or something.
Yeah, and then thanks for that. And then to answer the question a little bit more, yeah, Memfault will work pretty much on any RTOS you throw at us. So as Chris was saying, they use the ESP IDF, and then they also were using an STM32, probably running a similar RTOS, whether it's ThreadX or Zephyr or NCS. Memfault kind of works out of the box on the majority of the RTOSs unless you write your own, and then we'll need to integrate that. But yeah, pretty much any of the commercial ones out there. And then answering another question for that's Memfault specific is Bond is in kind of home automation and business automation in that space, but like what other industries is Memfault into? A lot of smart buildings, honestly, a lot of industrial applications. We're deployed in smart cities. So like if there's trash cans, there's sensors kind of in cities around the world. Memfault's often used in those appliances. We're in buoys out in the middle of the ocean. I think we're maybe in one satellite now, or like a couple of satellites. Wearables, so consumer electronics is popular for us, given that the industry that we came from. I would say Memfault is kind of everywhere. You walk into a home or a building nowadays, you'll likely find something that's using Memfault, which is awesome. Let me see if there's any more questions that have come in. But yeah, no, I think actually we're out of time. Thank you, Chris, so much for the presentation, for all the information, for kind of bringing your stories, also teaching me about bats. I'm going to go research Wikipedia about bats and fact check you. Of course, as everyone here should. Yeah, if you want to have a final spiel on where people go to find out more information about Bond Home, maybe you're hiring at the moment, any sort of sales pitch you want to give?
Well, if you're looking to automate motorized shades in your home, check out bondhome.io. And if you want to learn more about bats, I really recommend The Blind Watchmaker by Richard Dawkins. And yeah, thanks so much for the opportunity to share our story.
Great. And yeah, thank you all for attending. We're going to close up now and check out Memfault. We're happy to basically have any sort of introduction call, or you can send us a hello@memfault.com email. We're happy to answer any questions you have. Thanks for participating with all the questions. I hope we answered, I guess, the majority of them. Sorry, we won't take any sort of raised hand, but feel free to email us hello@memfault.com, and we're happy to answer any more questions you have. Thank you all so much for attending. Have a great day.